Alright, right now the gauge is off right now, and you can see it's showing just below 0 right now. And we have our buck converter device that we installed here to drop the voltage down to around 2.5 volts roughly. 2 volts, 2.5 volts roughly. We've tuned it a little bit. It's actually got a little dial on it. I can dial it in a little bit. And this is what we got out of it. We're going to start it up. Alright, this is first when you turn it to run. You see the gauge comes up just a hair there. That's in run right now. Okay. Because they're showing the resistance on that sending unit right now. Just turn it on. And that's about idle. It's still got some fairly warmed up. It's reading a little low, but it actually is pretty good. I mean, you can see it's like at the 85 pounds. I'll try to keep it within that range there. It's just a kind of a large range anyway for a vehicle, but anyway, let me rev it up a little bit. Back to idle here. Very good. Okay, but because it's running on low voltage, I want to show you the level of interference. This is a magnetized screwdriver, but it's pretty weak. It's not a strong magnet or anything, but watch this. That's what I'm talking about. When you're running very low voltage to something, you're going to be subject to a lot more interference on it. I mean, magnets obviously are going to be the largest amount of interference, but any kind of electricity, the whole instrumentation can cause inductive fields to play havoc on kind of a low voltage device. So let's see where it's pretty good. Turn it off again here. Let's see what it does. Alright, that's off. This is back to run. And this is starting it. It works. It works. It's there. It does. It's not. I would say it's not 100%. But I'd say the car to start with is probably 90%. I think we've got it at 85 or 80%. So I think, in comparison to obviously a modern gauge, it's obviously not even close. But I'd say it's pretty good for what we got.